Let's start off with the doing exciting part of doing the raffle. So I hope you've all got your raffle tickets and you haven't lost them. If you have, I'm sorry, you can't participate in this part of the show. There are some incredible prizes up for grabs. But what we're going to do is pull a name out of the box, or a number out of the box. What number do we have?
You want to read it out? It is.
Read it out.
56. Yes.
So you can actually this, or you have a check.
Carefully. Careful how you do. I'll take programming Kotlin.
Amazing. Thank you. Okay. Right, number 2 is.
Isn't it? Yellow. 13. Oh, yes.
Yes. Oh, we've got. Okay, so we've got choice of these, or we've got JetBrains licenses. Oh, should have said what the price. Okay, next one.
Still yellow. 19.
19, 19.
9. Came for the pizza.
You didn't want the second time.
Just tell me when to stop. I'll carry on. 7. 57. Who tried to play these for it? Unfortunately, there won't be time for our talk to me. 38. Yay! % discount that time. It should be a choose, shouldn't it? You're the other people didn't. Yeah.
Okay, got 2 more.
Okay, number 2. I want to look at this clapping anymore. No.
And the last one.
The clapping for this evening is all done. 57 is here. Is that the you got it.
Go. Okay, thank you. Congratulations, Paul.
Thank you. There's one sticker left. You just leave that. Let's say go. Oh, go, yeah. Go. Okay then. What do I call it?
No, Zoom did something. I don't understand what's going on.
Oh, okay.
I press escape. Thanks. Zoom. I don't know how to exit the screen now.
Oh, right.
Wait. Okay, this works now.
Okay. Hello. I'm Duncan. This is Dmitry. Well, we don't know what it was anymore because we lost the first slide. But the second slide is refactoring to Expressive Kotlin. It is our also our talk for Kotlin Conf. We're not as polished today. I think we discovered that we're not as polished today. Think of this as the provincial theatre warm up to like a stadium tour. We're trying out a bit of material. Some of this material you when we're on TV or if you go to the O2. Some of the material won't make it, depending on your reaction. So laugh loudly, cry. Lots of feedback, please. There's a script. We're still working. So expectations are low, but please afterwards feedback on what's working and what isn't, because we've got a lot of material and we sort of pick bits of it to try out here this evening. Thank you for your forbearance. What do we have, Dmitry?
well, we have the next slide, which asks the question of what is expressive. And I wasn't very original, I just did a screenshot from the dictionary. And it says that it's effectively conveying thoughts or feeling. So yeah, effective, conveying sounds good. Some examples that, well, synonyms, that it's meaningful, not a bad thing, right? The interesting one is that it's emotional. So didn't like that initially. And I like this example. He gave an expressive shrug. Like, I wonder, could you do it in your code? Like, do an expressive shrug. Yeah, maybe emojis. Right? So why expressive?
Why expressive? So we thought about this, and I mean, like, studies show that programmers spend about 400 hours a week reading code, and only 30 seconds a week writing code. And so obviously, with that sort of ratio, it is all about how quickly we can understand what's going on. So now, not necessarily, how important is it? We don't know. But we also feel that, like, we're craftsmen, we're poets, we're expressive people. Like the part of the point of Kotlin, I think, as Dave was demonstrating earlier, is that we can have fun with it. And so we like to have fun with it. We like to be expressive, and we like also maybe the code that just sort of works, that we can't break. That would also be nice. So when we read it, it does what we think it does. And if we try and change it, it doesn't break in other ways. Those two things are nice.
So yeah, so as I understood it, there are two reasons: economical, that it's just profit, and the other is just because we do it as a people, like people like nice things. So should we actually do it?
We can't have nice things.
So to actually do it, we will reuse this code base called yield-draws TDD. Duncan has been, it's YouTube-driven development. Duncan has been working on it for 2 years, video once a week. So
to be fair, Dave told me to stop doing that, and I stopped doing it for a while. But we're coming back now.
That's the code base. So we'll switch to IntelliJ. You might have seen this.
So introducing the app, it's a stock control system for Gilded Rose Inc. You may have you've done the Gilded Rose refactoring kata. That was the old code. No one liked that. Basically, they binned it, and we were employed to rewrite from scratch. We're an extreme programming team. We did stories, we did TDD, we've done refactoring, and a whole bunch of other stuff. The code is currently being migrated from Alison's desk, the machine that's sitting under Alison's desk, to the cloud. So it's sort of in a sort of state of flux where it's reading and writing from flat files as well as database. That may come up, I don't know. And this is what it looks like. With the actual CSS, it looks a lot nicer, but that's under NDA, so I'm afraid. This is what you've got. We can click things and delete. We can't add anything yet, but like delete works. Oh, actually, you can add, I think. Yeah, because you can type stuff in at the top and then press the add button and so on. There's a bit of HTML behind it. It is HTTP for K. I'd like to say it's Postgres, but the one we're running here actually is H2. Yeah, it works.
We have tests.
We have tests? Yeah, we always certainly have tests. And you can see that when that little bar goes across there, we run the test. So we've some places where we haven't yet got around to applying our newfound expressive Kotlin knowledge. We were young once, we wrote some code, and we made a list of the places that, yeah, maybe we'd like to, and you maybe help us. So we're going to start with configuring. Configuring with the place, and so I don't know whether font size is a thing we have any choice over. Should I make it bigger? I don't know. Maybe make it smaller. I don't know. How is it? It's okay. Man, they gave an expressive shrug. So what have we got? We've got Hikari data source for. So that's a little place where somebody obviously like copied and pasted some Java, and it ended up. Right? It needs a return statement. It creates a thing. It goes and configures that thing. And being Java, really, it's a mutable thing. So we would like that to be nicer. What have we got, Dmitry?
Put it in alt-tent everywhere, see what happens. There's nothing IntelliJ doesn't suggest.
Okay, IntelliJ is useless to us. Okay. We could try, so there's, in these cases, like I like apply. Apply says that I am, in this scope, I'm going to use this object, and outside this scope, this object is done, right? We're done with it. We just set up this little scope, and we have to do that tedious manual stuff to make that work.
Yeah.
But when we do, then results basically, the unconfigured object hasn't escaped from this scope. Well, they're called scope functions because they make a nice scope. And that would mean that we could make it into a single expression, and we all know that
The only usage, right? Can line make it into expression.
yeah, that sort of thing. There's a lot of like apply is almost like also. We'll see also in a minute, but you can actually just like convert it. So good old IntelliJ will do that for us.
I'm sure you know. The interesting thing, like you could, if I go back and I convert this to setters, then there is alt-tent. I convert them back to. So there is a refactoring. It's just like when you do assignments, it's not available. So I don't know.
We haven't reported that on the bug.
No, not yet. Shall I commit this?
Yeah, what we'll do is like we'll commit it, just sort of ratchet it up, and maybe things will build.
Next.
Splendid. So so let's say in this maybe in that function maybe let's go where we are there. So in there, let's say we want to the problem is like this db config comes from some environment stuff up there somewhere, and we want to debug it a little bit. So let's say we want to know what the db config jdbc URL is, and so we would now we need to print that. Well, we can't just print on it because it's there, right? So, but we could extract it as a local variable.
We actually could, right?
Yes. But anyway, so let's extract it as a local variable.
Oh, okay. So you mean just
yeah.
extract this as a local variable.
Yes. And then let's move that outside. So because we want to know about it before.
Oh,
yeah, that's irritating, isn't it? Yeah. Never quite right.
No. IntelliJ doesn't like it. Gonna do the function.
You won't believe that this is a talk being accepted by JetBrains, would you? So now we can pull that outside here, but the problem is we've got this nice sort of single expression. And then if we pull that URL outside that apply block, we're stuck. But
so you mean convert this to block body?
We'd have to do that, yes, and then we'd have to move that out there. And I quite often end up doing this sort of thing just in order to get a little variable out. But we have ways again with scope functions of not doing that sort of thing. And in this case, I think also is our friend.
So
if we inline that back again.
Do also. Then
yeah. So also like takes the thing on the left hand side and it actually returns it, but allows us to do little side effects. Just this little there's that, and also just
reference or not.
I don't do references, but you can. I'm an unsophisticated programmer. So also for that sort of thing, basically again, like it finds its own little scope, and it doesn't change the expression origin. We haven't had to go down to a statement. We haven't had to create a new variable. Like this one so much that we end up with defining printed.
I think he invented it.
And printed basically just says.
Oh yeah, if you look it up.
Basically just does that thing.
There is also definition for iterables, which I find useful. So it prints them on separate lines. Right. So we're not going to commit this, right? It's temporary.
Yeah, it's just a temporary thing. Also, again, like very, very occasionally, also end up in production code for me. Like we did this thing, and also we did that thing. Maybe we'll see it. Maybe we'll see it later. Okay. Good. So we've seen a little bit of run. Run basically just makes this scope that we can do stuff in secretly almost. Apply. That's good for creating objects and configuring them in one little scope. Also, side effects. A little bit also. But there is apply, and also like just a question of whether we're using the receiver or we've got a parameter. DSL context for here, I mean, that might be another place. So looking at this, we've got a data source, and then we're validating the data source. Well, that feels like data source, also validate source. Yeah.
I guess it's also interesting you get the option of all four.
Okay.
How would you choose? Okay, I guess my intuition would be also for non-essential side effect, right?
Well, except it is essential, isn't it? I don't know, but yeah. So, I mean, maybe your team will think differently, but this is the way that I think about it. Obviously,
I guess that's the example when I wouldn't use a reference. It's a bit too long.
It is interesting, isn't it? Yeah.
If only I could import that.
If only you could import that. It's strange that you can't, isn't it? It's almost like import a program.
And this is the only usage, so I would line it and put on separate lines like that. I think this.
Yeah, let's do that, and we'll see whether we can dig ourselves out of that hole later. Okay, so we've looked at applied, run, also, and Dave points out with. So let's have a look somewhere.
Run there.
We did briefly.
Okay.
Yeah. Like I don't know how to use run. Like I only ever use run if I need to set up a scope in a constructor or something.
Where are we going now?
So we're going to go to dual items. Oh no, we're not. Sorry, we're going to go to DB items. Okay, didn't see that. Nothing to see there. So this project uses Duke. Duke has this idea of a DSL context. It's an irritating.
We're looking at this function, right?
We could look at this function. Why not? Yeah, let's look at this one. So items here is Duke's definition of a table, and then like items has these properties that are its representation of the column in the table.
So do you mind if I read the code? So we have a stock list, and then we extract items which we want to save, right? And then we just go through each of them and execute SQL.
Yes.
Okay, yeah, makes sense. And items is Duke, which generated table. So.
Yes. Yeah. So the issue here is just like that tedious, like even like just the tedious items. So when we don't want to say items, we say with. We just say with items. And so up to conscious in view whether we do it there or maybe outside here, we can increase or decrease that scope.
This essentially.
So inside that scope, items becomes this. Well, it becomes this because we discovered that this is a comment. So, but because it's a this and because we never have to say this, except when we have to say this, we can basically get rid of it. And this just shortens this code. And it's sort of like, what is the primary thing we're thinking about here? This is the subject of this bit of code. Not quite like with, as Dave points out, it's useful for bringing objects into scope in the same way as we bring imports into scope. So I think I had the phrase, what did I say? I said, with is like an import from a variable. So that's good. If we moved items all the way out, then we would have been able to make that a single expression. But we could do the same in load, maybe.
I have a question. Like, your argument was that's repetition. Why don't you have another way on item? Right? What about this? Right, and this is where we discovered that this has so many meanings here, right? There is this with, guess which with, this safe, right? Safe is from the function, and this is where I wouldn't use with or apply. Well, like apply on a standalone function is fine. As soon as you have extension or outer class, if you specify explicit this like this, then it's kind of clear. But then there are implicit ifs. This is like this, and then this is where it gets messy. And then the problem is that it's like you might have a name which implicit with works, but then someone changes object in another scope which is closer, and it like overtakes it if it's the same type. So yeah. Basically, I'll undo this bit.
It was a bit of a straw man there, wasn't it? Like, what happens if you do this and don't do that? Of course, context receivers will mean we're doing this all the time. And maybe that's a good thing, I don't know. Like, so in the end, we have to decide how explicit we want to be and how much we can cope with the explicit that we have decided to enforce ourselves. Sometimes the details aren't important and we just try and hide them away. Sometimes the details are crucial and we have to accentuate them. In this case, we're saying the details are like where those columns come from are intuitive, if you like, if we make this code expressive enough.
My other tiny rant on ergonomics of ID is that if you use this, you cannot highlight it, so I'm pressing highlight. But if it was converted to, well, I cannot convert it, but if you have explicit variables, you can highlight them. If you cannot highlight where this from function is used, this from with is used, you cannot just find it. That's the other downside of expressiveness.
Yes, and often we see that the IDE is like, we write code that's kind of expressive and hides stuff away, and then the IDE makes these little grey things that are trying to tell us the stuff that we were trying to hide away. So it's great if you want to print it out, it's nice and terse, but otherwise you're just seeing all that stuff anyway. I tend to switch it off. I want the code to be as I wrote it. See the code that I wrote. Okay, so we looked at with about. It's a good name with this thing. Do that stuff. Shall we have a look at let? Let's have a look at quality. So here's quality. We talked about value classes a little bit. Well, maybe talk about value classes a little bit. This is stupid now. This is a value class representing a non-negative int, and we've got this. We've got a factory for it. This is not values for k. We have a factory for it that says you try and build me on an int.
Oh, so you factory mean this invoke.
That factory,
which pretends to be a constructor.
Yeah, luckily Dave warmed everyone up, so they are so on.
So wrapped.
Yeah, so we've got this. We want to say, can we? So non-negative int is a very similar thing. Basically, it will return null if you can't create a non-negative int because the value you're trying to do long was negative.
Plus the now.
There you go. Yeah,
you can imagine.
So the issue here is sort of, well, it's a bit long, and we have to ask questions about null and so on. So we have a little refactoring. Let. And
wrapped.
Yeah, so my goal is I say do that and then that. Now I can move that stuff inside. Like that, yes. So that's now the same code. Can we just run the test before we get one? So that's doing the same thing. But in this special case here, oh yeah, you pull the return out. Yeah, that's good. And now we've got a single expression. We love single expressions. So. And now we've got this tedious sort of wrapped null, but we know that we could have wrapped not null if we use question mark.
Yeah, and then this is redundant.
Yeah.
So
that's nice.
Maybe it's
again.
I think there is an interesting thing. I bet if I go back to the original, if I alt enter in the right place, if expression, let's say, it just does the whole thing pretty much.
Yeah, that's it. So that's one refactoring, a bonus refactoring for you, but only seems to work, unfortunately, like if it is actually, it's got a crazy name, like it doesn't say,
it's good if it's there, but if it's not there, follow the steps, Duncan.
Yeah, I would follow Duncan. Okay, so let is also got this sort of, what let is really doing is it's taking a thing on the left-hand side of something and putting it onto the right-hand side. So it's like swapping the thing into a block for us. And that can be quite useful. So let's have a look at configuring, which is my favorite place in this code base. And let's have a look. If we look at DSL using that, where is it? Yeah, that little block. So the issue we've got here is that when you read this, you like to have to turn your brain inside out. You have to know as a computer programmer that in order to call DSL using, it has to evaluate the statements that are going to be passed into DSL using. So you're very used to it, but it's like you're used to turning like these calls inside out. And in particular, like when we're also doing other things, it turns out, that's a bit sort of tedious. So if we hadn't have done that, then we've made that a variable, then we'd be back to kind of where we were before, but it would at least be in the order that it actually happens, right? So the expressions we're evaluating here are on the screen in the order that they actually happen, whereas if we put them into a function invocation, they're not on the screen in the order they actually happen. But we can use let to kind of solve that problem. We saw it with we saw it before. We can do that thing, yeah. And so let has now taken the thing on the left-hand side, made the first thing we do, and then allowed it to be available on the right-hand side. Now we can only do it for one parameter unless we get silly with like making tuples and things and passing them and destructuring them. So don't overdo it. But in this case, there's only one thing, only one variable that we're passing into the DSL, and so that works. And there now we've got this nice little chain. We're actually doing a thing. We're doing a thing. We're doing a thing. That's interesting. But also, there's this relationship between let and extension functions. So if we made this, if we put an extension of DSL uses equals like that,
like this?
No, not that one. No, not that one. Right. The one down there. So line 26. So if you've taken that expression and made a function out of it, and next would be Dmitry on his own. That would have been like DSL context 4. So,
right.
Back one. So that is DSL context for something, and when these things are in this order, then that's why we end up with wanting our let. Fine. But if we made our it there, the Hikari data source, into a receiver, then you notice even IntelliJ is clever enough. This becomes like 2 DSL context.
Oh, 2 DSL.
Yes. So I like 2, right? So when I'm extension function that's just taking a thing and converting something to something.
That's all. Remove this.
Oh,
format and IntelliJ. It wasn't me.
Just go and show people that, because that was the money. Yeah. So at this point, IntelliJ says, "Oh look, let's no use to you here because you've already got this piping thing, yeah. So it actually lets us remove the let. And so there's a relationship between let and extension functions. Sometimes we use extension functions. I often make things with extension functions, but if I'm calling something else that just happens to have a parameter and I can't be bothered to make it, then that will allow us to just make this nice little chain. And languages like F# have a sort of pipe operator that allows you to go this, and just lay things out. Okay, did anyone time this, by the way? How are we doing for time? Nobody has yeah, the time is still moving. So now we've got rid of the let. Hikari data source 4, I mean, that also feels like an extension function now.
Should it?
Yeah, I mean, extension function all things, always. So this sort of highlights an issue that we have with multiple thises, right? Because it turns out that JDBC URL is part of both the name in dbconfig and the thing that we're setting into.
This goes to apply. Yeah. This goes to the function, and the names are the same. So if I do this, this is now referring to the wrong.
You can take that out
because the names are the same. That's the problem.
So IntelliJ was quite clever. If you take out the this at, it will still compile, and if you run it,
it will not work.
It fails actually because the JDBC URL you're setting there is the one from Hikari data source, which was null. And it goes, you can't set a null. Well, it could be a null if that's that.
Should we go back to parameter?
Yeah, it's difficult to know what to do for there, isn't it? But
yeah, my sense would be extract a function. If it's use and apply. What I did, select this 3 lines, extract function, refactor. Goes into this, then don't need to apply, kind of. Yeah. I'll undo this.
So we've looked at these, we've made a nice little pipeline here. I'm looking at line 23 and I'm looking at that, and that's DSL context for a dbconfig, right? That again, like we're just converting from one thing to another. So Yeah, I reckon, and so that will be DSL context to DSL context. So all these conversions just boom, 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 boom. Now we could look at where that's called, but it's not very interesting. But it does beg the question now. This file is the file with dbconfig in it, right? So now we've got an extension on a function on a type that's literally just here. And you might say, why
Not move into the class.
why not move it in? Yeah. So unfortunately, there doesn't seem to be a way to do that automatically. So we have to like, if we want to do that, we can like this. But actually, we'll break a few compiling things because we were actually importing them. So quicker than the eye can see. But there we go.
That works, right?
But
We can
this,
move it back though, right? There is a refactoring to convert member to extension. Can easily go back to this.
yes.
But,
But now, why might we wanted a method and why might we want an extension? We might wanted a method if it was polymorphic, but in this case, all it's really doing is coupling our DSL context. Sorry, coupling our whatever this class is, dbconfig, just completely coincidence that Dave used such. That's wonderful, thank you. That we don't have a port notice. It basically means that you can't use dbconfig without Hikari data source and without DSL context. So we've now made it so this dbconfig object carries around knowledge of all those technologies. And dbconfig, like you could use it just native with Postgres or whatever. You don't need to use a connection pool for it. None of those things. It's just data at that point. So an extension function allows us to disconnect those two things in a way that I think we probably should. So I think we should probably make that
back to.
yeah.
What about the constructor then?
Well, the constructor then shows that. I mean, like much as we like HTTP environments, and they're brilliant, maybe we don't want to couple our plain old data class to that. And if we didn't, then maybe we could just pull that out into a function that we could put somewhere else in our code base.
A bit messy.
It's going to be messy.
Then equals dbconfig.
Yeah, that was quick enough, there wasn't it? We can go. And again, as Dave says, you're allowed to create a function with a capital letter. It returns the same type of thing. Maybe
Cool.
even some super fast. So I think there's a relationship then between where we put our functionality and coupling. We don't know what we mean by cohesion, but we do know what we mean by coupling. We do know that coupling is bad. Cohesion's good, but we don't know what it is. Coupling, we know what it is. I think I'm bored of scope functions.
Yeah, the short summary.
There is a short summary. So these are our views. Anyways.
Yeah, well, I think like my summary would be like applied for configuration of mutable objects, unless it's very nested lots of ifs. Also for non-essential side effects, like maybe login, things like that. With, I'm not convinced, but you said to live receivers.
Yeah. But also we also had that phrase that we should have put in the slide, which was, it's like import for values.
Nice, I like that. And then imports are just like parameters, right? And then let, I like let, it's like you said, for piping, pipe everything. It's cool, and extension functions. That's more meaningful let, or more meaningful apply.
This idea of piping is just that idea that we say things in the order that we mean them, which I think is probably present.
It depends on what you want to express. You want to express the structure of nested objects, and that's more important than execution flow. Then, yeah. Yeah, and that's it. What's next?
So the other example we've chosen is, Dave picked them up to call them tiny types. They are things with that kind of like normal types, but just distinguish between one use of a type and another. So let's have a look at item. Okay, so here's an item. We've got item and priced item. They are the same except one of them is priced. And you see, we've sort of attempted a little bit to differentiate between ID and name, which is the type alias for ID. But actually, that doesn't stop us just mixing them up, to be honest with you, because type alias is a string is just a string. Doesn't matter whether we type alias it or not. So this is, I mean, that's kind of expressive, but it's not protecting us in any way at all. We'd like it to protect us.
So I guess the protection is these two lines, right? We cannot construct item with blank ID or name.
Yes, both those things. But unfortunately, that's not expressed in the type system. That's not a thing that anyone can know really, unless we wrote it in Java doc, or I don't know what we could put it as, as a comment on. Nobody reads comments. So what we're going to explore is differentiating between IDs and names and the other types here, with actually introducing types, proper types of them, rather than just strings or type alias strings. And we've got, we'll see how this refactoring goes. It's a bit of an experiment. I made it up this morning. I was on a clock this morning if that happens. So, but I did make notes. So let's see how it goes. What we're going to do is we're going to start by introducing another type alias for our item.
Item name, you mean?
Item name, that's good, and that's also a string at the moment. So, and then we can use it in this place, right? And we can also use it in price item. Yeah, let's put it. That's right. So far that should compile and be fine.
Yeah. Well, that's just like using string, right?
Oh yeah.
So that was give so much
You'd
safety.
be amazed at how I can break code. So now, if we actually had a type, we would have a constructor of that type. So we need some way of taking a parameter in order to be of that type. So what we're going to do is we're going to fake that. We're going to say, if we had a function whose name was item name, that would be like a constructor, right? And it would take a value, string. And for now, and it would return an item name, obviously, but we're just going to return the thing that we just got. Which hasn't got very far, but now we're going to go and find the places that we are, like, where in our system those strings are created. Yeah. And IntelliJ has this. Whoa, get back. I mean, you're keen. What we're going to do, we're going to do this methodically. We're going to go to item and name, the property. Sorry,
All right.
down tools.
Yes. Yes. So we go to the name. And
and now we're going to say analyze data flow to here. So what IntelliJ will do is go all the way out, if you like, along the paths that get into here and find those places for us.
So that's more advanced than find usages, right?
It is more advanced than find usages. So kind of like finds the edges, which is fun. So now we can go through these and we see, look, here's a place. I don't know what central item is, but at that point, that's a place where we got a string and it's plugged into an item. You see it directly here. Yes. Okay, so here we are mapping from record 5. There's a Duke thing. And one of the strings that come out is the item name. So we're just going to wrap that again.
Right. So we're doing this everywhere the same.
We're doing it everywhere. I'm surprised you haven't finished.
This one?
That's the place, yeah. That's another place, yeah. So it's a little bit tedious, but like we haven't broken anything yet, which is quite nice. So we get a choice. We could go for a wee right now and come back, and it will be fine.
That's done.
Okay. So we really, I mean, we probably added actually a function call. We could have inlined the constructor actually, and we wouldn't have added a function call. So we've not really changed anything. But what we have done is we've made it so that we have to call this item name at the edges of our system. Okay. Now there are two ways we go, and we're going to go the sort of slightly tedious break-it this time, because I haven't practiced it all. So what we're going to do now is we're going to say, now we're in a position to change from our type alias to actually a class. So we're going to make that now And we might as well make it an inline class.
Why did I with an item name, right? And it will have val stream, yeah, stream. That's it.
And so now we've basically, the function has been replaced by the constructor. It's quite sweet. And, but now, unfortunately, like we can't, well, actually, just a little thing. Let's try, can we make this item name implement char sequence? Oh. Does that make that? Does that compile now? Oh, yeah,
well, at least this one.
Yeah. Okay.
There will be more though.
So there are a few places that take char sequence, like it's not blank.
I think the problem with this is just a bit fractal when you get compilation errors. We saw 2 errors, that was the current file. We fixed those, now we have like 5 more. And then after this, we'll probably get tests because Gradle compiles them separately. So great times. We don't even know how many errors we have basically at any point. No, that's the problem.
For those of us that wrote C++ and we're used to 5,000 errors and just, when it showed you absolutely everything, I kind of prefer this drip feeding. It gives you hope, it gives you hope.
I'm doing dot value everywhere.
So basically now all the places that we needed a string, we're not a string anymore, which is unfortunate because it would be nice if our data classes could be a string, but they can't. So we're just going to suck it up. We're going to type the values.
That's it now. Yeah. I think it's not that. That's it.
Okay, and then run the tests. And okay, yes, live TV folks. What's the failure?
I think this.
No, I'm not.
We do that name value, and that will work.
No, it won't.
Oh, that was 2 string maybe.
Days pay. If you're confident, bet days pay.
What's that? We should look at the error, right?
Look at the error. Okay. So what have we got? We've got yeah, there we are. Like so. So because we wrapped it in the class, we got the 2 string from the class. So instead of name, so basically we just added 2 string.
Turns value.
Yeah. Because previously, every time we were putting out an item name, we would just get the string, so we want the same thing.
Could be value as well.
We can make that a value class, and in which case, yeah, it's all pretty much the same. Okay, so I think that's quite cool, and there's a sort of side effect here now, because all the times we get an item name, we've been through this particular bit of code, we can move the require up into our item name. And we're building the item names on the outside of our system now. So it means that we can't get an item name. If we do this, we can't get an item name that is blank. And it turns out that there was nowhere in our system that did, and we kind of knew that because all our item names were being passed into these 2. But that's quite nice, good. The only problem is that we're still left with it not really communicating the fact that. We'll check that in, by the way, if you haven't already. Good. The only problem is that we're not communicating about the fact that you can't build a blank item. We're still able to call this constructor. It will just die if you do it. So maybe we could do better than that. So if we were to do better than that, then we want one of Dave's famous not actually constructors, right? Because your constructor has to return the actual type, item name. But we want it to return something that is an item name. It could be a result where it said this can't be blank, but actually just none of them will do, right? Because the only way you can fail to build an item name, the only reason you can fail to build one is write down the blank string.
So we want to compile an object.
Yeah, let's just go straight for it. These people want to go.
Fine.
Operator fine. Operator fine.
Oh, it almost guessed that thing.
That's pretty good.
Question mark. Doing.
So we type
value blank.
Name here, no doubt, but yeah.
Yeah. Then else we return. I think that's not wrong.
I think it's not wrong. I mean, we might, yeah.
But it says like leave to return.
Yeah, and then that's the same expression, is it? Okay, so now it turns out that probably, I guess we're still calling the constructor. The rules must be that we call the constructor if it's there, but if we made the constructor now private, we would probably find, yeah, there are, so now we're there.
But can we do it a bit more gradual way? As I, what type? We'll try if I was really doing so this. I deprecated it. The monkey. Whenever we use it, it's like,
Oh, I like that.
it doesn't show the monkey though, it's like so frustrating. The monkey.
That there, where the monkey should be.
So, yeah, and then we can go one by one and replace.
That's
it.
a really good idea, let's do that.
Pilot. So yeah,
Yeah.
which usage would you start with?
Philippines.
This one?
Yeah.
Been here before.
Okay, so this is not an item.
Oh, I think there will be a small problem that it cannot be deprecated, actually, it has to be private. Because how do we even say that we do invoke? Only like this, right? And then it becomes nullable. So being private is actually crucial.
Yeah, I don't know.
It is, unfortunately, for monkey. Now it's like back to compilation.
Okay, back to the compilation errors. I'll give you 5 seconds to fix them all. So in this case, okay. So, just before we go. So in this case, like this is production code. Should we, like, is it okay to double bang in production code? Almost never. In this case here, where you can actually see that you don't have a blank string here.
The next one.
Okay, next one. This one's interesting, right? So this one, we actually have a database constraint that says that field can't be null, but we want to know whether that fails. You can see we've got if blank on the items, but we needn't use that. Actually, we can now just call the constructor and use Elvis. That's quite sweet, and then we can do the same. Again, that's an error because we've got a constraint. It would be a programming error for that to never happen. What do we have here? Item name on name. So it's a bit tedious, but I think we're doing the same thing there, right? So
this, right, and fail is blank, which we have committed.
yeah, but I would make name item name on parts. Using Elvis rather than if blank.
Yes, of course, it makes sense. We're doing okay, we're doing this.
Yeah,
item.
yeah, you are. It turns out. And I think there actually is a blank name. That's handy.
And this is right up.
Name. How are we doing? Okay, name lens, oh, that's a bit tedious.
And then for now,
So we can change the name lens to be a non-blank string, thanks Dave.
that's sort of DT lens.
But it doesn't really help us with this bit here. We could map the lens into something probably, we tried that and gave up. So I think we are basically going to double bang that one. This is test case. Yeah, so this is tests.
Test.
So this is actually a special, like, just a test item factory.
I find it interesting because item is all tiny typed here, or we're trying to end this in test, we're just using strings. So I guess this is where you draw the boundary between the code you care about and the code you care about.
I think it is because the tests are are not a boundary of our system with the actual outside world. They're a boundary of the system with like developers. We typed everything that ends up in the tests.
And this one.
This one's interesting because here we're doing item name on name value, but that is just name.
Yeah,
Which is quite sweet actually. So now we've seen that this thing has pushed its way forward.
then here's
Kind of banana is definitely not.
what is this? Then from
This
calculating
one
that.
is- Yeah.
Okay, are we done? No.
Oh, so
Wait,
both.
wait.
Beat from the jaws of victory.
It works, it works. I'll commit this.
Okay. I
This is,
think that's all our examples, is it?
yeah,
Hooray.
tiny types.
What have we done?
Just the idea that the safer.
Yeah.
Yes.
I mean, so we came into this with more expressive, but like we came for the more expressive, we stayed for the safer. So there's this phrase pass don't validate. So what we've actually done is we've moved we've moved the non-acceptance in this case of non-blank strings from inside our system where we built items to like on the outside of our system where we built the type that we're going to pass into our item eventually.
I think what's useful like that it provides navigation. In case you need it, you can find all item names. But how do you find streams which are used for item names can be really hard. In some way, my argument why you would consider time. Imagine you have like a structure with 8 properties, right? If you have 8, you just named class in Kotlin Java. 7, all happy to 4. 3 is like maybe named class, maybe triple. Named class for pair, yeah, sometimes. Then like what do you do with 1? Like pretty much the default, just like you just use it, right? But this is where the tiny type comes in, because if you apply the same consistent rules, that whenever you have a thing like data structure, you give it a type, and that will go along with nominal type system like in Java and Kotlin, unlike TypeScript where it's just structured everything. It's interesting about 0, so maybe it's a tiny object. Maybe you want to distinguish different units of functions.
Maybe a new the tiny objects.
Yeah, that's true. And yeah, as you have heard, there is values for k you can carry. Did you write it down, Nisha? I think you did.
Yeah.
Okay. And that's the end of the demo.
Do you have any concluding thoughts?
Yeah, wow.
So one of the things that sort of came to us as we were writing this is that we talked about expressive Kotlin, but actually Kotlin is an expression-oriented language. And so often I think Kotlin becomes more expressive when we will on that thread. We were sort of inspired by this. If you haven't seen the talk, it was at the second Kotlin Conf in Amsterdam. Second Kotlin Conf that was in Amsterdam. I don't think Lisa went quite far enough, but she was interested in talking about the ways we communicate through code.
Especially at the beginning, I thought it was, getting to expressive, those lots of small refactorings there, like tidy apps from this book by Back tidy first. So that's like, I think tidy apps is like a rebranded refactoring for small things, and particularly getting to more expressive, like scope functions that we showed. So I did a bit of a blog post, like tidy Kotlin with small refactorings, how I would write expressive. And Duncan did his YouTube channel.
Yeah,
I did should.
This is what I do.
Believe it.
I'd like to have a living.
Not yet.
Send that not at all. No.
Yeah.
Thank you. I think we're done. Feedback, please. Like that should. No Zoom.
No. Was that one?
When somebody plays the video back, can you let us know how long it was?
Yeah, we'll let you know. We'll get over, I think. It was 50 minutes.
Oh, it was 50 minutes last night. Oh, okay.
I've got some cutting to do.
So, hello.
So when I think it's for the item name, you introduced the companion object, and then you made the constructor private. Or do you at that point get rid of the require?
Oh, well, Dmitry and I argue about this.
Oh, sorry.
I mean, yes, obviously. Well, I said not yes, obviously. But I mean, obviously, yes. You could. Should you? Well, I mean, it's code that's going to be run every time you build an item name, and you're going to build quite a few item names. If you care about efficiency, then yes. If you care about the fact that somebody may come along and break your code later, then maybe leave it in, because it's, belt braces, nothing wrong with belt braces. This is a way of communicating things about this class in a way that is executably demonstrable. So I would leave it in because I worry about people coming along and changing these things later and not understanding what they're doing there. You might take it out because you want to use it in a hot path, then you can.
If it makes you feel better, I would do this.
See what mood I'm in.
So when you wrap the when you did the data flow analysis, and then you ran a couple of items with the item name. I think, I'm not too sure, but I think that could have been automated by, say, by the refactor, by changing the signature, and then introduce another property with a random name, with a default value item name, with the name inside it, and then inline name should be go inside it.
I was going to ask a very similar question.
Please tell me that that's on the recording.
Yeah. I had the same question. It's really interesting. But I was wondering if instead you could use it with structural search and replace.
Nobody can use structural search and replace. That's not true, actually. Luis can use structural search and replace, but I don't know anyone else who can.
Because it's a nice refactor for things like Ellis, in like that.
Yeah.
I imagine if you have like hundreds of thousands, so yes, I do that manually, right?
Absolutely. We have been looking for a cuter way of doing that. And as you say, like the cute ways of doing things are where you're able to find something that compiles in the same way as the thing you've got. Yeah. And then you're able to change the implementation of that and then inline it. That's a really sweet refactor.
Yeah, we tried different ways. We tried that, and the way it would work with the secondary constructor. But then the problem when you inline only one layer of things, but you actually want to push tiny types all the way. So you kind of have to go and search for it through each usage in here. But yeah, absolutely you can. Yeah,
thank you. If you see that,
you paid attention. Like, oh my god, how did you manage that?
If you see that Kotlin conf, we won't credit you, but thank you.
Hello. Can you also talk about the fact you shouldn't probably iterate over a list and insert them one by one into the database?
I think, well, yes, yeah. We're only inserting a few things in data. It's true. We should batch those things up. Thank you. To be fair, he's actually in the transaction. At least that.
Sorry, it's a pet peeve of mine.
Yeah. Anything we hated? Too fast, too slow? Obviously not too slow.
Too few IntelliJ bugs.
Yeah. And actually IntelliJ didn't just crash and go away. Yeah. Which does seem to be a lot just recently. Yeah. I would like to do some more stuff. I'd like to do some stuff on like there's something about DSLs maybe, and I don't know what you get rid of. So if anyone's got any opinions on what we could get rid of from that, please tell us or tell me now. What he said. Information.
So on that note, we're looking to head to the ball, which is just down on the right in Devonshire Row. And thanks everyone for coming. Thank you, Duncan, Dmitry, David, policy expert. We are looking for hosts for our next meetup. So if your company use Kotlin and want to contribute to the community, give me a shout. Thank you.